Hello everyone, so I want to share my experiences with Handmade Hero. This is, I think, one of the most amazing series that you can find in game development by Xlib. He is, if you don't know him, he is an awesome game engine developer. And like back in 2014, he decided to start streaming and sharing the way he built games from scratch, basically, no libraries, nothing, so that people like us could learn how computers work. And I think that's an amazing gift. So today what I want to share is how to do that in the Linux platform. So one of the things that it was hard for me at first was, okay, he's developing for Windows. I haven't used Windows in more than a decade. So back when I was in college, I had to do a lot of scientific computing work, and that required me to learn Linux. And I decided, okay, Windows platform is not doing me any good. I feel slow working with Windows and using commands there. So I decided to switch to Linux entirely, and that's my operating system every day. That's what I use. And not only that, as a gamer, I always wanted to learn how to create games, and that's really, really difficult. I tried reading Quake II source code, and it took me a lot of time, I'm saying months, and I didn't get to finish it. But then I found this series and I was like, okay, this is amazing. Because one thing is to see the whole code, and another is to see a developer doing it just in front of your eyes, and you following along and learning. So this is for everyone else like me that wants to learn more. And I'm just gonna share how to open a window in Linux. Something similar to what Casey did in for Win32 applications. I don't use Emacs, I use Vim. I'm not gonna argue about that. I tried it once, but I actually don't remember, it was so long ago, how the experience was. So I also tried using IDEs, but I'm not gonna talk that much about that. So my editor of choice is Vim. So I'm gonna go to the temp directory. I'm gonna do all my work there. So I'm gonna open Vim, and let's work with the Linux handmade.c. And I know that Casey doesn't use any libraries, but if you're like me, you're beginning, it's okay to use the libraries provided by the C standard library. Later on, as you advance through the series, you can start replacing all that code. And I'm sure that he shows how to do that. I haven't gotten that long so ahead in the series. I'm just beginning. I'm practically seeing not even 20 episodes. But still, I thought that I could share some of my experience for anyone who wants to do something like this in Linux. So I'm gonna start by including, my typing is terrible today. Standard IO.h. Okay, so one thing that you will notice is, okay, Casey did this with C++, and I'm gonna use C. I'm going to use C because that was the first language that I learned in college. And I really like it very much, and I think that I can work with this. So I'm just going to include the standard IO library for input, the standard library as well, because I use some of those functions. And I'm going to define main. Here, difference with Casey is that you don't define main, but on Linux you do have to define main. Main is not your entry point. Your entry point is defined by the C runtime, which is gonna call main. And okay, so we're gonna need Xlib. Yeah, Xlib.h. Okay, so how do we even start to do this? So my first search was, okay, how do I create a window in Linux? And I'm going to open another terminal. I use man pages, and I think that they're great. It's a little old school, yeah, but I don't have to use the internet to get information that I need. So I can check X, create simple window. I think that's the name, right? Okay, here is the man page for this function and related functions here. So what we're gonna do is pretty much do something similar to what Casey did. So to create a simple window in Linux with Xlib, we need to pass in the display, a parent, some coordinates, dimensions, width and height, the border width of your window. I think this is the border color and the background color. So all that we need to pass in. And I'm going to start with that, but I think it makes sense. The first thing that you want to do, okay, how do I open a window in Linux? Is just copy this function, and let's copy that and put it here. Okay, let's use this. Okay, this is not, let me see if this is, yeah, this is not very good. I usually don't like doing this, copying the entire signature. So what I'm gonna do is I'm gonna type it myself. Sorry guys. There are some things that one has to do. So we have to pass a display pointer. I'm gonna use display. We need to pass parent. Okay, we don't need to this, right? And yeah, I'm gonna have this. So I'm gonna have parent is a root window. I'm gonna go back to that. We also need to pass X and Y. This can be 0. The same thing as in Windows, the top left corner of your screen is gonna be coordinate 0, 0, 0x and 0y. The width and height, we can get it. We can use defaults also, so that's similar to what Casey did. The depth is the depth of the screen. This is possibly 24 bytes. What we're gonna do is we're gonna store it. We're gonna use some Xlib macros to get it. And the class, this is a window class. Since we want to do input and output, input means we're gonna capture, for example, keyboard input from the user, and output means we're gonna display graphics. So we need a class which is input output. And the visual, okay, so I see my little mistake here. I started using create window. Sorry guys, but let me see. I don't need to specify the class for a simple window. So after height and the width and the height and the border width, which can be 0, I think that I also don't need to specify what is the screen depth. Right, so we can use 0. Sorry for that, guys. And okay, these are colors. If you go here, it has a description for each one of the arguments. Here, border, it says specifies the border pixel value of the window. This is probably 0, but Xlib defines a macro black pixel of screen. So let's use that. Okay. And this is an unsigned long, and I'm gonna say this is a black pixel. Okay. Black pixel of screen. So as you may guess, we need to provide screen pointer to this function also. So let's pass this here, the black pixel. Probably I will want to use another name for this one, because Xlib defines another macro which is named black pixel. So I'm going to use black pixel value, and probably the last value is going to be also a color. So this is probably everything that we need exactly. This is the background color. I like windows with black background, so I'm gonna use black pixel value also there. So to verify, we need to provide a display, a parent window. I'm gonna go back to that, X and Y position, the dimensions, width and height of the window. 0 is the border width of our window, it can be 0, and these colors. So to provide the display, you may notice that the man pages sometimes provides some additional info. Unfortunately, in here it doesn't say the one that I was looking for. X open display, which is a related function. So here is gonna return, this function is gonna return a pointer to display, which is what we need. And the display name, it's not the name of the window. Essentially, you'll pass null. We can look for this if you're interested. Display name specifies the hardware display name. So here it is. Usually, you will use null or 0. So this is what we're gonna do. We're gonna define. Okay, we need a display pointer, and we're gonna use X open display, and we're gonna pass null to it. Now, something that we should do, I'm not gonna type it in. This could fail, and in that case, display is gonna be null pointer, and your program is gonna crash immediately, and you should handle the error and this and that. But I'm not gonna do it because I don't wanna write so many error handling cases. Okay, in this example, this code sample I'm giving you, there are not gonna be many cases, but to make it more dynamic, I think, I'm not gonna write it. You shouldn't do it. You should check if the pointer is null. Okay, so we could start, right now we could start trying to compile, but this is gonna fail because parent is not defined. So this is another one of those macros that you have to use in order to get what is the parent window of this simple window. I think I can use default root window right here. So I need now to check what are the arguments. I think it's just display, so I'm gonna try to type it in. We need to pass a pointer to display, and man X, yeah, it's default root window. Okay, let's look it up. Full root window only requires display. So one thing that I learned was that Xlib defines macros, and those do not start with an X. Those that start with an X are probably a type or some function that could be called from other languages like C++. So if you're using C++, you probably have to call X default root window because the macro might not work in that case, I believe. So now we have defined the parent, the width and height. We can also use defaults. Width, let's see, width of screen. Yeah, we can use that macro, and we can check what is going to be. It's not listed here, I think. So we have to look for it. Width of screen. Let's go. What do we need? We need a pointer to a screen. So we are gonna need the default screen probably. So screen, and possibly default screen. Here it is. So probably all that we need to pass in is display, and we can verify this default screen. As you can see, this becomes really tedious, especially if you're trying to do it for the first time, looking through all these documentation. And that's why I started with trying to create a window and see what do we need, because doing this first might seem like, why are you doing all of this? Well, because the function signature requires it. So, okay, we have verified that this returns what we need, a pointer to the screen. So we have the dimensions, we only have the width. So surely there's one for the height. Let's do that. Okay, now we have the default width and height, and the black pixel value. These should compile, but before trying to do that, let's do xclose display, and then we pass our pointer so that we get a clean run at least, no memory leaks or anything like that. Okay, so let's go to the temp directory, and I'm going to use gcc right on the command line. I'm gonna enable all warnings. I like debugging info, we're gonna need it. And our source file is, let me see how I named this. Oh, Linux Handmade C. And I'm gonna call this, okay, Linux Handmade bin of binary. You can use exe if you would like to, but I'm gonna use this one. And then we need to pass Xlib as a parameter. So let's compile this and let's see what it's complaining about. So probably let's see, from inmates pointer. Okay, default screen, probably I used the wrong macro. Default screen, let's check here, default screen, because there are two versions. This one, default screen of display, which only takes a pointer to display. So the right macro was default screen of display. We can try to compile the code again and see what other problems we have. Okay, so apparently I'm missing a parenthesis in line 14. Okay, let's see. Oh, right. I have this. This is our window. I forgot to define the variable that we're gonna store this to. Okay, let's do this again. Okay. Unused variable window is a warning. It's complaining that this variable is not being used. Okay, if the compiles, so we can test it. So let's do that. Linux Handmade bin, and boom, nothing happens. We can check that the code did not crash by checking the return code. If it's 0, like in this case, that means that the main program ran properly. So all that we did was create a window, but the window, just by doing that, is not going to display. This is the thing about Xlib programming. You need to wait for the window to show up. You need to map the window. So let's look at another function here, xmap window, I believe. Right. So for the window to display, you need to map it. So you have to pass a pointer to display and the window handle. So let's do that. Xmap window. We pass display and our window handle. And we try to compile again and see what happens. And then we execute. And nothing happened. And that was not altogether unexpected. In addition to that, we have to wait for that event to actually happen. Or maybe our program ran too fast. We need to make it pause. So there is a function in Linux that is named pause, but this is not like Windows pause. It's gonna wait for a signal. So I'm going to implement a very basic version of it, but I'm gonna define that as internal. And I'm following Casey here. So any internal functions are meant to be, in this case, at the platform level, which is the Linux. You're not gonna be able to call this from anywhere else. I know I'm doing this in the main function, but eventually we can move all this code to another function. And it's gonna be accessible only to the functions within that source file. So let's do that. Internal void, I'm gonna call it Linux pause, because Linux defines pause function, but in a uni standard header. and I don't want to define a name collision or anything like that, so I have to change its name. So what we're gonna do here is just to attempt to read from standard input. And actually, the way I like to do that is by using the unique standard error, actually. So I need to read from the standard input, and I think this is the file descriptor, for the file that I'm trying to read. In this case, you remember, if you know Linux, pretty much everything is a file. So in this case, standard input has a file number. We need a buffer. I'm just going to use the address of C, which I'm going to define size of C. In this case, C is going to be a character type. It's just 1 byte. So what this application is going to try to do is just read 1 byte from the standard input. But before doing that, we're going to tell the user to press a key. Okay, this is the format. Press any key to continue. And we print a new line. So pretty much this is a really basic implementation of a pause. We know that reading is going to block the execution of the program until the user presses a key from the keyboard. So we can use that right here. Linux pause. It needs no parameters, and we can try to compile this again. There we go. And we at least see that it reached that point where the window doesn't show, but at least it goes to this portion of the file where it pauses. So at least we have that running, and we can tell that it's not an issue of that the code ran too fast. It did the mapping of the window, but the window still doesn't display. And this is one of the things that I found on the web, like, okay, this happens a lot. Pretty much the first time that you are programming this thing. So I'm going to clear the event, and we have to wait. Let me see, what is it that I have to do? Okay, probably if I use autocomplete here, it could X window event. I think it is right. That's the function. So many functions. Okay, max window event. We can see the information here. So to do that, we pass the display. Sorry, we need to pass a window handle. We have to tell, okay, what event are we listening to? Are we waiting for it to happen? And this is a pointer to the X event structure, which is gonna write to it. So we need to pass, as usual, the display, the window. I'm going to wait for the user to press a key, or maybe I can wait for exposure mask. And I need to pass the address of the event structure. And now we can compile the game. Well, it's not a game yet, but it will be. And here is our window. Okay, as you can see, it's a black window. We can resize it any way we want, and this is really cool. We can do all that while waiting. It's actually, the code is still waiting. Oh, right. You can see here that something really interesting has happened. When previously, if you look at the output here, it says press any key to continue, and not here. So what happened is that this is also a blocking function. If this doesn't happen, this kind of event doesn't occur, this function is gonna block execution further down the line, so we never reach this point. And the reason for that is that we didn't tell Xlib that we actually care about exposure events. And this is in part because we're using a very simple window. and by default, this very simple window is not going to care about this. So we, in our code, we have to change some of the attributes of the window so that we can tell it, hey, we care about exposure mask and possibly keyboard input events. So we have to do that. But at least what I wanted to show you is that it displaying a window in Linux with Xlib, it's kind of a lot of work, and you can easily get stuck because of things like this. So as you can guess, I had to read a lot of documentation from Xlib and to find about these issues. So some on purpose, some I have done on purpose, some because it's hard to remember so many details. But we have no choice here. We will have to close this window. And so we kill explicitly, we kill the X server, in this case, our connection to the X server. And we can check that this is indeed cause an error, because it's not going to return 0, it actually returns 1. It means that the program pretty much encountered an unexpected error. We can check also that the memory that we requested for opening the display is pretty much lost when we do the same. Okay, probably this is not gonna work because I forgot a little detail about valgrind, but let's see. Okay, but still, okay, it's not so bad. This memory is still reachable, which means that the operating system can handle this and clean up this after us, and so this is not so bad. And in fact, if our application suddenly crashes for something like that, the operating system is going to handle this apparently, and we have really not leaked memory in this case. So it's a very cool tool that I like to use sometimes to check the memory leaks in my programs whenever I'm doing C or C++. So here it says an issue with dwarf 2.3 block. So we have to compile the code so that valgrind understand this debugging info. So let's actually do that and let's see what happens. So what we have to do is pass a block size that it can handle. We're gonna use dwarf 4. And let's run this again. Okay, we're gonna encounter the same error. So we have to close the window, but we see that it only gives us the heap summary. Sorry guys. Okay, so the same thing, but no warning. So that was critical. Okay, so what do we do from here? Let me see. We have to modify the attributes of this window. I believe we can use exchange. I'm going to use autocomplete here, exchange window attributes. So let's look for the map page for that one. I'm gonna open it right here. Exchange window attributes. Okay, let's see what it says. Okay, we need to pass a display, again, a window handle, a value mask, and this data structure, xset window attributes, and we have to pass a pointer. So this is essentially, we need to pass a template of window attributes. So let's do that. And let's define it, xset window attributes. Sorry here. Xset window attributes. You know, we have to pass display window. For some reason it's not, the autocomplete is not working for me in this case. Window, what is it that we care about in this case? Let's say we want to capture keyboard input. All right, so we have to do something like this event. We are modifying the event mask of this attribute. So we need to pass this flag, the window event mask, and the template, the attribute template. So, oh right, yeah. Right, I made a mistake here, sorry guys. These are the parameters for this function, and this is the type, okay, and this is the template. And we're going to zero initialize it, just like Casey usually recommends. This is the way he does it. So we need to say, okay, event mask, we are going to must modify this. So what do we care about? Possibly keyword input, key press mask, and key release mask. I'm gonna use those, only those two, key press and key release mask, and this probably should work. And I have to define these attributes before actually waiting on them. Okay, so let's move that code here. And right, I have display window and my template, but it has to be the address of the template so that it can use that information. Right, the information is right here. We can verify it expects a pointer to X that window attributes structure. So I think we're pretty much good to go, but I'm going to wait for a key press mask. Okay, this is what I'm going to do, and let's hope that this time this works. Okay, so now we compile. I'm not going to use valgrind anymore. Okay, and I'm going to press a key, and there we have it, my friends. Press any key to continue, which means that it actually waited until either a key press or a key release, and since it now is now ready to listen for those events, so it's not going to ignore them, and this call is not going to block. As soon as the user presses a key, this is going to happen, and we're going to continue. So usually you don't need to do this kind of stuff. If you look at, you can keep modifying things. Like, for example, if you look at Quake source code, you can see that there are more attributes set. And in fact, I'm going to show you, because I use Quake source code to learn some of these things. So I have it here. Okay, VR, Linux, read write, possibly near X create, not image, X create, window near here. Okay, so this is the template that they use. So let's go back a little bit, and they use this standard event mask. They said, okay, these are all the events that we care about. These are defined, that is right here. So they have key press, key release. They also have exposure mask. So this is the one I was looking for. We can add this also. Exposure mask. As you may recall, some folks on the stream ask whether these bitwise operations are used very often, and you can see that in Linux it's pretty much the same. So I believe it's pretty much a standard in all software development, low level, very much. You're gonna encounter these things. Getting used to this, it's really cool. Okay, so let's try to change this. So instead of waiting for the user to press a key, let's pass in here the exposure mask. So we're waiting for this other event so that the user doesn't have to actually input anything on the keyboard, so that this won't block. So without me doing anything, it should continue to the Linux pause. So all that I'm going to do is I'm going to recompile this and then run this, and now I'm going to switch with my mouse so that you see here I didn't touch any key in all this time, so it kept on going, it didn't block. The exposure mask event occurred, listen to this event and go all the way till this point, and now we can simply pause. So I think this is it's still not usable code, but at least it shows you the minimal code that you need to create a simple window in Linux that allows you to listen to key presses, key releases, and this exposure mask, which is a very simple way of waiting for the window to show up and not blocking your code further down. And then closing the display. So obviously at some point here, we are not gonna have Linux pause, probably. You're probably gonna have your game loop here some running. And here is gonna be your game loop at the beginning pretty much of the series before he starts refactoring the code. That's about episode 10 on API design. But I think that this is the minimal code that can help you get started with the Linux development. So I hope that you enjoyed this, video, and that you found it somewhat useful to you. If you have any comments, please write. You would like more from this type of tutorial or information, sure, I'll make time for you to do that. I would love to help you guys. So I know that I spend I don't know how many hours looking on the internet to learn stuff, so it's only right to, I think, eventually one gets the chance to share knowledge to others, and that's why I like open source a lot. So guys, take care, thank you for watching, and do follow this Handmade Hero series. You're not going to regret it. You're going to learn so much. So once again, until the next time, take care guys.